All right, we're going to start today by looking at polynomials this week and through half of next week. Our first quiz is on polynomials, all the operations. But first, before we learn that, we got to learn what is a polynomial. Okay? So, break down the word polynomial. The first part of the word, poly, means what? Many, multiple, very good. Many or multiple. And then nomials refers to something as well. What? Not just numbers, terms. Terms can be numbers alone, could be variables alone, or could be a mix. Okay? So we're looking at expressions with many terms. All right, so a technical definition here, polynomial is the sum of one or more terms. One or more terms. Okay? Now, how do you know it's a sum? Is that they're adding and subtracting between terms. That's what actually separates terms. Terms are separated by adding and subtraction. So again, you can tell that you're moving from one term to the next, the first to the second to the third term, by seeing them separated by an addition sign or a subtraction sign. Okay? That separates terms. All right, there are 5 examples, 1, 2, 3, 4, 5, of what standard form looks like. These are all different number of terms, different degrees. We'll look at that later. But can you see a pattern in these 5 examples? Can you see how this is in a certain order? Yes?
The exponents are ranged highest to lowest.
The exponents are ranged highest to lowest. He said it better than I can. The exponents go from the largest exponent and they decrease going left to right. Look at the first one. 2x squared. Well, nothing else with it. Negative 7x to the third and then x to the 1. X squared, x to the 1. What would be the exponent on plus 7? X to the... No, that'd be 7x. X to the 0. X to the 0. X to the third, and then the constant term. X to the 11, x to the 5, x to the 4, and then the constants. So we can see a standard form is an ordered expression. The largest exponent first, and then decreasing down from there. All right, so we're looking at parts of a polynomial. In this example, this is actually, is it in standard form? Yes, because why? The largest exponent term is first. X to the 5th term is first. And then the next biggest is x to the 2nd. So yeah, we are in decreasing order of the powers. All right? But there's more to it than just that. We could identify the number of terms. We see that they are separated by this addition and subtraction. Just prove that there are 3 terms in this example. Okay. 1, 2, and 3. Another important thing, like I said earlier, is that biggest power. Okay? That biggest power is what? 5. The power only here. So 5 is the biggest power there. That's going to tell you the degree. Okay? Your largest power is the degree. The largest power is the degree. So for my example, this is a degree what? 5. Or you could say a 5th degree. Okay. We ignore the smaller exponents. We take the largest one and say this is a 5th degree polynomial. Okay. Also important about that first term there is not only the largest exponents, but we're also going to take that value, the 7, and identify that as the leading coefficient. Leading coefficients. All of these important parts can only be identified in standard form. You might see it in other forms, but make sure you're in standard form. So leading coefficient here is just the number 7. Okay, don't forget, this will always be with the largest power. Okay, it's the coefficient of term with the largest exponent or power. All right, we forgot one important part before our textbook work here. That's our constant term. That's the last term in standard order. The last term in standard order. Why is it the last term?
Lowest coefficient.
It has the lowest exponent. What's the exponent there for the x that's missing? 0. This is the constant term. The thing that does not have a variable. Does not have a variable. No variable. The non-variable term. All right, here's the first table on page 356, number 10. So we're given the term 4x to the 5th. We see they already gave us the answer for the degree. That's the exponent. That matches right there. What's the coefficient? The number in front, 4. Okay. What's the next example's degree? 3. The exponent is 3. Okay. There's its coefficient of 12. What's the degree of the third example? 2. Again, that's the exponent. And what's the coefficient? 1. The invisible 1 that's out in front right there. What about the degree of the last example there? 1. X, negative x to the 1 power. The invisible 1 right there. And what's my coefficient then? Negative 1. That's a negative 1. Okay. If I had another example, which I want you to add right here really quick. Something like maybe negative 13. What's the degree of that? 0. Very good. A constant term will always have a degree of 0. And the coefficients, you could say negative 13. I would agree with that because you could have written this as negative 13 times x to the 0. All right, here for number 12, we're looking at for the degree and constant term for this one. The first one, the constant term, the thing that has no variable is 7. So 7 is the constant term. What's the degree for the second example? 3. Your largest exponent is 3. And my constant term would be negative 3. All right, last example there. What would be the degree? 2. Even though it's way over here, out of standard form order, it still is a second degree polynomial. And the constant term is still 36, even though it's first. Okay? All right, so just like polygons that have a certain number of sides, it has a special name for it. Like a 5-sided polygon is a pentagon. A 4-sided polygon is a quadrilateral. 3-sided is a triangle, right? So we also have names for polynomials. Okay, so if a polynomial has a certain number of terms, it has a special name for it. So for example, a one-term polynomial is known as, anyone? Awesome. A monomial. That's the only kind of polynomial you could distribute the powers on, shower the powers on. Okay, it's only on monomials. You won't be able to do it with the rest of these. What is a two-term? Well, you guys are smart. That's right. It's a binomial. We're talking about the prefixes here. Mono is 1, bi is 2, and nomial is terms. So I think we all can figure out what a 3-term is. Very good. All right, or should I say a good try there? Oh, I know. Oh, I can't spell either. I can't make jokes and spell at the same time. All right, there's that prefix, trinomial. All right, let's keep going then. What about a 4-term polynomial? Is it a quadrilateral nomial? Is it a quadratic? Is it a four-nomial?
Yes.
No. In actuality, there's no more names left. 4 or more are known as polynomials.
What?
That's right. 4 or more terms. They don't get special names. They're just known as polynomials. But before we conclude, how could I distinguish between different polynomials? What else could I do? If it's more than 4, I can't do anything. How else could I describe a polynomial?
If it has 5 or
If it has 4 or more, yes, it's going to be a polynomial. But is there other things we could say about polynomials that could be more descriptive for that thing? Maybe something like the degree, very good. Or something like the leading coefficient. Or something like the constant, right? So we could get really descriptive with polynomials. All right, may the math be with you.